Here m is nothing but mass of the substance, C is nothing but the specific heat capacity of a substance, delta T is change in temperature. So what is the formula? That is Q is equal to K into A T2 minus T1 into T divided by L. Latent heat is nothing but amount of heat required to change the state of unit mass of a substance into another state. Hello everyone, welcome to session 5 of chapter 11 Thermal Properties of Matter. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, so far till last session we have discussed about the theory part of this chapter, Thermal Properties of Matter, where we had a discussion about how does the matter behave with respect to a temperature or heat. For change in temperature or heat, what is the behavior of matter that we can observe, and lot more concepts regarding to this. In today's session, we are going to solve few numericals from the chapter Thermal Properties of Matter. So let us now begin with the first problem. A man wraps himself in a flannel of 4 mm thick. How much heat will be lost per square meter of his body per hour? If the atmospheric temperature is 20 degrees Celsius, the coefficient of thermal conductivity is given by K is equal to 5.03 into 10 raised to minus 2 watt per meter per Kelvin, and the temperature of the human body is 37 degrees Celsius and it is assumed to be a constant. So here we have to find out what is the amount of heat that lasts per square meter. Per square meter means area is equal to, per means 1, square meter is nothing but meter square. So area is given 1 meter square, and per hour. So per hour is nothing but T equals 1 hour, which is equal to 3600 seconds. So if the atmospheric temperature is 20 degrees Celsius, K for the flannel, K is nothing but the coefficient of thermal conductivity. It is 5.03 into 10 raised to minus 2. The temperature of the human body is 37 degrees Celsius. That is, T1 is nothing but 20 degrees Celsius. T2 is equal to 37 degrees Celsius. So we need to find what? The amount of heat lost per square meter. So what is the formula? That is Q is equal to K into A T2 minus T1 into T divided by L. What is L here? L is nothing but the 4 millimeter thickness. So L is 4 millimeter, or we can write it as 4 into 10 power minus 3 meter, or it can be written as 0.004 meter. So K is 5.03 into 10 raised to minus 2. A is 1 meter square, so 1, and T2 is 37, T1 is 20, small t is 3600 seconds divided by L, that is 4 millimeter, 4 into 10 raised to minus 3 meter. And the answer 7.65 into 10 power 5. Since they have asked us to find the heat, the answer is joule. So 7.65 into 10 power 5 joule amount of heat will be lost per square meter per hour. So let us move on to the next problem. How much heat is released when 5 grams of water at 20 degrees Celsius changes into ice at 0 degrees Celsius? So to change water into ice, what is the heat that should be released when the mass of the substance given is 5 grams. So take the specific heat capacity of water is 4200 joule per kg per Kelvin. Specific latent heat of fusion of ice is nothing but 3,36,000 joule per kg. So these are the given data, and we have to find the amount of heat released to notice the change in the state. So now total heat energy we have to find out. So total heat energy is nothing but sum of specific heat plus latent heat. So what is specific heat and latent heat definition? We have already studied in our theory class. Now specific heat is nothing but mc into delta T is the formula, and latent heat is nothing but amount of heat required to change the state of unit mass of a substance into another state. So here it is latent heat of fusion of ice is given. So it is nothing but m into L. Here M is nothing but mass of the substance, C is nothing but the specific heat capacity of a substance, delta T is change in temperature. And here M is nothing but the mass, L is the latent heat of fusion. Now let us substitute all the values from the given data and let us find the total heat energy that is released. So in the data, M is nothing but the mass, which is 5 grams, and the temperature, which is changing from 20 degrees Celsius to at 0 degrees Celsius. So 20 minus 0 is nothing but 20 degree only. And specific heat capacity, that is C, is 4200 joule per kg per Kelvin, and specific latent heat of fusion is given by 336,000 joule per kg. Now we have all the values. Let us substitute in the formula and we get 5 into C value is nothing but 4200 and delta T is nothing but 20 plus M is 5 and latent heat L is 336,000. So multiplying this, I'll get 4,20,000 plus I'll get multiplying this, I'll get 16,80,000. Now let us add these two to get the total heat energy. So taking sum of this, we'll get 21 into 10 power 5 joule is the total heat energy which is released when 5 gram of water at 20 degrees Celsius changes into ice at 0 degree Celsius. So our next problem is a 100 watt light bulb generates 95 watt of heat which is dissipated through a glass bulb of radius 3 centimeter and the thickness is 1 millimeter. What is the temperature difference between the inner and outer surfaces of glass bulb? And the coefficient of thermal conductivity of the gas is given, that is 0.84 watt per meter per Kelvin. Now we have to find the temperature difference. So we know what is the formula which includes coefficient of thermal conductivity, temperature difference and the heat with thickness, everything. So that is nothing but Q, which is equal to K into A into T2 minus T1 into T divided by L. So the temperature difference can be calculated as delta T is equal to H into L divided by K into A from the formula, that is amount of heat dissipated or rate of flow of heat. And here H value is given, L is given, K is also given, but we don't know the value of A. So how to find the value of A? So radius value is given. So we can make use of the formula pi r square, that is 3.14 into radius is 3 centimeters. So that is nothing but 3 into 10 power minus 2 the whole square. And the answer for area is 0.0942 meter square is the area. So now let us find the temperature difference. So the temperature difference delta T is equal to H is nothing but the 95 watt of heat it is given. So it is 95 into thickness is given, that is 1 millimeter. 1 millimeter is nothing but 1 into 10 power minus 3 meter divided by K value is given, that is 0.84 and A value we have calculated just now, that is 0.0942. 0.0942 and solving this we will get the temperature difference and the value is 402.54 Kelvin. Since we are calculating the difference in temperature, the unit must be Kelvin. So let's move on to the next problem. Calculate the rate of flow of heat through a glass window 2 meter cross 1.5 meter, that is length into breadth. So the area is given and 3.2 millimeter thick. If the temperatures at the inner and outer surfaces are 15 degree and 14 degree Celsius respectively, the thermal conductivity coefficient for a glass is given, that is 0.84 watt per meter per Kelvin. So here we have to find the rate of flow of heat. The area of the window is given. So what is the area of the window? That is 2 into 1.5, that is length and breadth. So we will get as 3 meter square. The thickness of the window is also given. So thickness is given as 3.2 millimeter, which is nothing but 3.2 into 10 power minus 3 meter. And the temperature difference is given, that is T1 is equal to 15 degrees Celsius, T2 is equal to 14 degrees Celsius, and the coefficient of thermal conductivity is 0.84 watt per meter per Kelvin. We need to find the rate of flow of heat, that is delta Q divided by delta T, which can be calculated by the formula K into A T2 minus T1 divided by L. So let us substitute the values now. So it is nothing but 0.84 into area is nothing but 3, and T2 minus T1, that is 15 minus 14 divided by length. L is nothing but the thickness, that is 3.2 into 10 power minus 3, or we can write it as 0.0032 is the conversion. Now solving this, we will get the answer as 2.52 into 1 divided by, here we have 0.0032, and if you multiply 2.52 with 1, we will get 2.52 only, divided by 0.032 gives us the answer 787.5 joule per second. Is the rate of loss of heat is nothing but 787.5 joule per second is what the answer for our question. So like this, we need to analyze the data and let us find answers and the relevant formula where we have to apply the given data to find the suitable answers. So numerical from this chapter is very important exam point of view. I wish all of you to try with different examples, and in the next session we'll start up with a new chapter. Until then, take care all of you. Thank you.